Et voici le moment des quickies de la fin de journée. Dans les films d'horreur, on a l'habitude de voir les entrailles des gens. Mais là, Simon va nous parler des entrailles de Ubuntu. Ce talk est en anglais, mais Simon parle français. Donc si vous voulez aller le rencontrer après, ça peut être très simplement fait en français. Merci d'accueillir chaleureusement Simon.
Hi. Again, this is in English. First, I have to apologize for anybody who was hoping to use subtitles to follow this. I forgot to provide abbreviations in jargon files, so this might get a bit wonky at times because there's a lot of jargon to go through. So this talk is about the anatomy of a Linux system, and who am I to give it? Is a software engineer at Canonical, the company behind Ubuntu, in which I work in the Ubuntu Foundations team. So that's kind of my job to wade through those internals. So why am I giving this talk and why am I giving it now? So I'm sure some of you are familiar with the feeling of receiving a notification, an email, or saying, oh, there's an urgent CVE on libfoo. And you're just, wait, what's libfoo? Why does it matter? So since Ubuntu Jammy came out, that was in 2022, our security team has fixed in the default server install. That's you just download a Ubuntu VM, you run it, and on that system, 90 packages have been fixed where there were 550 CVEs, that's in 2 years, and that's not counting the kernel. So I'm sure that in those 90 packages, there are a lot you have never heard of. And in particular, the event that triggered my proposal for this talk was the XEutils backdoor in XEutils, but that was targeted at SSH, because even though I had heard of XEutils, I knew, of course, about SSH. I had no idea how the two of them were connected, because SSH does not use XZ compression. So that's kind of the idea here, is to give you a wide awareness of what's on your system and how it's not a monolithic block, but actually a patchwork of a lot of different projects. Since I am a canonical engineer, I am, of course, going to base this on Ubuntu. And even though I was talking about the default server install, I'm going to give you a tour of minimal Ubuntu. That's this subset of Ubuntu that's in every Ubuntu product. That's Ubuntu Desktop, Ubuntu Server, Ubuntu Containers, but also flavors like Lubuntu, Kubuntu, Ubuntu Studio. All of them have at least the minimal set. I'm using this set mostly because of time. This is only a quickie, but that set is not so small. In that set, we have, to build that set, we start by defining what we want. Those are what we call seeded packages. We actually defined 58 of those packages. From there, we build the dependency graph, and we come out with 225 binary packages built out of 157 source packages. So that's important. The notion of source package is basically your GitHub project. So that means that on the minimal set, we have 157 GitHub projects from a lot of different people that have nothing to do with each other. The only thing they have in common is that they are shipped by distributions such as Ubuntu. For context, we have more than 37,000 source packages in Ubuntu, building almost 100,000 binary packages. So in that context, the minimal set is actually minimal. But yeah, 225 binary packages, I'm not going to go through that in 20 minutes or even an hour. So I'm just going to look at the seeds and very roughly. The seeds are in two groups. First is the required, which is really the bare minimum. And then we have the minimal, which is a bit more user-friendly. In the required set, you have the package, which is your package manager. That's what you use to install deb files. You have base files, which builds your file system hierarchy. And then you have, of course, some shell tooling, so the shell itself, core utils like grep and awk. Then you have file system helpers, because it's nice to actually check that your file system is in good shape. You have enough to just log in as root and change your password. And a few tiny tools to configure your system, such as the host name or a few kernel parameters. That's it. That's what we have in the required seed. Note there is no kernel there. There is no init system there. It's just that. In the minimal seed, that's a superset of that, we add apt, which is the package manager that allows us to download packages off the Ubuntu servers and install them. That's kind of nice. But for that, we actually need networking support, so we had that too. Ubuntu is Linux for human beings, right? And human beings speak different languages, so we need to add localization. That's translations, but also time zones and keyboard configuration, because not everybody is using US QWERTY, especially here, I'm guessing. Then we add an init system. That's right. I'm not sure, but I think even the Docker image has an init system installed, even though it doesn't run. We add support for unprivileged users, because Ubuntu is famous for using sudo by default. And some hardware support. So we have vudev, and we also have eject, because apparently you cannot be called Ubuntu if you can't eject your CD tray from the command line. Who knew? So those are the seeds. Now there's more than 100 dependencies. I'm not going to go through them. I'm just going to highlight one of them. That's probably the most important one, especially for me because I maintain it. That would be glibc. glibc is a GNU C library. And if you walk the dependency tree from every seed, at the bottom of that tree, or the top, depending on how you walk it, you will find glibc, because glibc is not only the C library, but also the ELF interpreter, ELF. ELF stands for executable in library format. That means that every binary that you run on your system will actually first be interpreted by a little bit of glibc. When you install your package, however, you cannot install glibc. You will install libc6, libcbin, locals, and etc. So yeah, libc6, that's that. That's a very important part of your system. Now, I said every binary. That's not actually true. Golang users out there might not actually use glibc for everything, because native Golang binaries that have nothing to do with shared libraries will actually directly call the kernel. But that's a unicorn. That's just not the norm. Please do not confuse glibc with glib or GNUlib. Those are also C libraries. Those are somewhat related to GNU also, but not glibc, not the same. All right. So that's a very quick tour of Ubuntu. Width, very shallow. We didn't go into details. But remember the exeutil thing I mentioned? That was about OpenSSH, injecting a backdoor in OpenSSH. And I was wondering, wait, how are they related again? If you look at the OpenSSH dependencies on the Ubuntu package, you do not see anything related to exeutils. So I wanted to investigate. To investigate, I have used one of my favorite tools, which is called strace. Strace stands for syscall trace. As its name indicates, it traces system calls, and system calls are how you interact with the kernel. And that's basically how you do anything useful. If you don't interact with the kernel, you cannot write to any file, you cannot go to the network, you cannot print anything, you cannot display anything. So anything you want to do that's useful, you do it through a syscall at first. And one of the things that you do is open a file to load it. So if you load a shared library, the first thing you need to do is open the file. And we know how to load a library. That's through glibc that I mentioned earlier. So we can actually look at the glibc code. I'm not going to do that now, but I did it. I looked at the glibc code to find which system call is used to open a library file. And then I just traced it on OpenSSH. So the result that's kind of on the screen now. You can see the kind of information we get. That's a bit hard to decipher at first, but that's actually fairly useful because it tells me, for instance, that it's a file that we want to execute code from, which, yeah, is a good hint since it's a library. Now, the scenario we're going to go through is just use a standard Ubuntu 24.10 containers. So 24.10 is the one that just came out last week, right? We just enabled passwords on the SSH server. We modified the service file to wrap the SSHD daemon with strace. And then we start the server, we connect to it, we log out, and then we stop the, well, no, we can't stop the server because strace actually kind of screwed up system control. So I actually had to kill the server at that point. Do not try this on production, but do try this at home. So when you look at the logs right after you've started the server, you actually already see a lot of action. 18 libraries are loaded at startup. So if you come from the Node.js world or the REST world, that doesn't sound like a lot. If you come from the C world, that's starting to add up. It's not unreasonable, but that's still, yeah, on the high side. If you look at where those libraries come from, actually, it's a bit less. It only comes from 13 source packages, so 13 different projects. But that means they come from projects that are not OpenSSH. And that's all before we actually do anything. Now, those libraries, a good part of them are kind of expected. We have PAM and Kerberos that are both used for authentication. We have OpenSSL for crypto. Please do use a library for crypto. Do not code your own. That's a bad idea. But you also have libcom-air from the E2FS progs package. That one is a weird one. libcom-air is seemingly something to do with error handling. E2FS progs is something with the ext2 file system. So those are utils to deal with the ext2 file system. So I didn't really understand why it was in the mix, but it is in the mix. It is in those 18 libraries. But I mean, once the server started, then it all quiets down until we log in. And when we log in, that's when PAM actually starts doing its thing. I mentioned PAM earlier. It's in the 18 libraries that were loaded. It's an authentication framework, except that PAM stands for Pluggable Authentication Modules. Plugins are just shared libraries that you load during runtime. And there are quite a few plugins there. I counted 25 plugins. Most of them were self-contained. 2 of them actually had extra dependencies. One of them was PAMCap. It loads libcap, which is something to do with capabilities in the kernel. The other one is a bit more interesting. Is PAM systemd, and of course, it needs libsystemd. My guess is it is used to create a user session through login-d, but that's a guess. Do not take it to the bank. Now, interestingly, at that point, libsystemd doesn't load anything. But remember when I said it's a 24.10 containers, not a 24.04. 24.04 was back when the xeutils vulnerability was discovered. And back then, libsystemd would actually load 4 or 5 extra libraries, including liblzma, which was the one with the backdoor. Since then, they actually switched to a model where they only load libraries when they use them, which in our case is pretty good because that means we have less dependencies in OpenSSH. But we are still left with 40 plus libraries loaded in one single process. For those counting at home, that's also more than 16 different projects contributing code to one single process that's called Secure Shell. That kind of amazed me. And so the other steps are log out in, well, kill the server. Of course, kill the server, nothing is going on there. Log out, luckily, nothing is also going on. But you could actually imagine that there would be some extra steps taken there, like loading a logging library or something like that. My conclusion here is actually a shout out to Randall Munroe from XKCD. You might have seen it already because It has become quite famous in its 4 years of existence. And it's basically, are you all aware of the amount of small bricks underlying all of your servers? You are probably taking for granted that Apache is one single thing, or Nginx, or OpenSSH, or every one of those big projects that you are using to serve your actual workload. But it'd be interesting to actually look at what they are loading in turn, so that you could actually be aware of the severity, the actual severity of a CVE for your system. Now, I'm pretty much done here. So, do you guys have questions for me? You can ask them in French or in English. I'm fine with both, but I will answer in English.